Hello and thank you for watching the second lesson of chapter 3, which is 3.2 Protocols and Protocol Suites. Now, in the previous lesson, you have learned that devices to be able to communicate on the network, they have to follow rules. And those rules were called protocols. Now, protocols are created by standard organizations, and we have some protocols, they are proprietary protocols, which they belong to a specific organization only. So when you hear like a standard organization protocol or open standard protocol, that means that anybody can use them. You can pick, choose, use it. If it's proprietary, means the only company who owns that protocol can use it. And Cisco does have some proprietary protocols, which we're gonna be learning them anyway. So we learned that devices they do need to follow these rules to be able to communicate. And end devices and intermediary devices they implement protocols on the software, hardware, or both. And each protocol will have its own format and set of rules that they operate. Okay, so we have a protocols, for example, different type of protocols. So we have a network communication protocols. These protocols they will allow the devices to communicate on the network. For example, either in the remote network or local network. For example, we have a TCP protocol. This will enable the device to communicate reliably. Every time I send a segment, I make sure that we get acknowledgement. Yes, I got that segment. There's another protocol which we're going to be learning later called UDP, and that's best effort. It's not as reliable as TCP. It's reliable, but it's a best effort delivery. It doesn't make sure that segments got to the destination. We have IP, which we have IP version 4 and IP version 6. IP is like a logical addressing of the devices. We give an IP address so other devices can identify who they are, where they are, and so on. It's like a name really. And then HTTP, Hypertext Transfer Protocol. This is, for example, for web browsing. Every time you go to web browsing, do something on the Google or Chrome or anything, they're using HTTP. But these are communication protocol. Now we have a network security protocols, and the network security protocols they make sure that authentication, authorization, encryption, integrity it's there. For example, so we making sure that we authenticating the users or we authenticating the communication. We do have a data integrity there, making sure that nothing has changed from the source to the destination. And data encryption. If somebody reads, has a hand on that data, it will not be able to make sense of what we mean because it's all gibberish to them. So you need the key to understand what we're talking about. So we have a like for example, we have a secure shell, SSL, secure socket layer, or TLS, for example, for these communication. Then we have a routing protocols. Now routing protocols, routers will use that to make sure that they know all the paths from the source to destination and maintain those paths. For example, if one of the path fails, they will find a new path, how to get, and they will choose the best path from the source towards the destination. That's a routing protocol. We have different protocols. We have RIP. What happened there? Let me get rid of that. RIP, OSPF, and BGP. These protocols. And then we have a service discovery protocols. And these protocols will actually give IP addresses to the host. For example, the dynamic host configuration protocol will issue IP addresses to the end devices. DNS will be able to resolve domain name to an IP address. For example, say that you type in your browser, you type www.cisco.com. DNS will be saying, okay, well, computers don't work with names, yeah? Here's an IP address for that. You need an IP address. There you go. So there's quite different type of protocols, yeah. So some of them, well, in here I can see all of them are standard or open standard. So we have a protocol, the routing protocol, which we're gonna talk in the next slide, or next two slides, I think, in the second slide after the next, about proprietary protocols. Evolution of protocol suite. Now, protocol suite is a group of interrelated protocol necessary to perform communication function. So, for example, we have to have the application layer protocol, transport layer protocols, and internet layer protocol to communicate to each other with each other to be able to make that communication successful. The good news for you guys is that, not for me, it wasn't, for you, is that you don't need to learn any of these. You don't need to know any of that because everything now is going to TCP/IP. TCP/IP suite. Now, TCP/IP suite is maintained by Internet Engineering Task Force, IETF, and we have for example, here we have in TCP/IP model we have 4 layers, but TCP/IP suite, don't forget, has only 3 layers: application and transport and internet. There is no network access TCP/IP protocol in there. So in application layer, for example, of the TCP/IP model, we have the HTTP, Hypertext Transfer Protocol. This is for web browsing. DNS again for resolve IP addresses to names. We give a name, gives us an IP address. It can't do the other way around. We give an IP address, gives us a name. That's called a reverse lookup. If we give a name and he gives us an IP address, that's called forward lookup. Dynamic host configuration protocol. This is when we get an IP address from the server dynamically. And you can get an IP address for the end devices, or for any device, for example, statically or dynamically. And if we choose dynamically, then we use this server. Then we have a file transfer protocol, if you want to transfer some files. And I told you in the transport layer, we have 2 protocols. We have TCP, which is a reliable protocol. We're going to learn about these protocols a lot more later in our lessons. But TCP will make sure that all the segments, they get to the destination. And then if anything gets lost, it will resend them again. While UDP, it will chop the data into small pieces, and those pieces are called datagrams or segments. Either way, it's fine. But UDP is the best effort. So it's going to send this datagrams to the destination, but it's not going to make sure did the destination get those datagrams or not, or did they get lost or anything like that. Any protocol that actually uses UDP or any communication with UDP, it's just speed. When they want speed, for example, voice, video, or online gaming, will use UDP. But anyway, like I said, we're going to go a lot more in detail later on in our course about these 2 protocols, pretty much about all of the protocols. There's one chapter about these 2 protocols, there's one chapter about IPv4, there's one chapter about IPv6, and there's one chapter about ICMP. So you're going to go in detail about each one, and as well as Ethernet, WLAN, ARP, and so on. All of these are like a single chapter. I think this one is just one chapter altogether. IPv4 is a logical of addresses to end devices to the nodes. Every network device is going to have an IP address, either version 4 or version 6. Version 4 has 32 bits, while version 6 has 128 bits. We have ICMP version 4 and ICMP v6. ICMP is more used for troubleshooting or for informational, what's happening with our network. ICMP v6 has more features, which we're going to be learning, like we do Slack or neighbor discovery, neighbor solicitation, router advertisement, and so on. We're going to learn a lot more about these. But we have to have these protocols working together and understanding them so we can communicate with each other. For example, if you use TCP, TCP doesn't understand NDS, so they can't mix and match. So you have to have a suite for them to work together. And this is application transport and internet is the TCP/IP suite. And then we have a network access. You can see that all the different suites, they have the same network access. And here is a protocol suite. So for example, we have an open standard that is freely available to the public. We have a standard-based protocol suite endorsed by network industry and approved by standard organization. And we have a proprietary protocol owned by a single organization. In this slide, I have only one proprietary protocol, and I'm looking around, but I see this one. And this is Cisco, EIGRP, Enhanced Interior Gateway Routing Protocol. It's owned by Cisco, but Cisco has made it in 2012, has made it like other device, other companies can use it. So it made it open, but still owned by Cisco. So in the TCP/IP model, we have an application layer that's going to be the closest to the user. Then we have a transport layer, which is going to be how we deliver that data. We have an internet layer, and we have a network access. Now in the application layer, for example, we have a DNS, and like I said, resolves name to an IP address. DHCP gives an IP addresses or leases IP addresses to the devices. Whoever wants an IP address automatically, DHCP. BootP is a predecessor to DHCP. DHCP has made for example, got rid of BootP because we don't use the BootP. The only reason why I put it here, right, is because when we do, for example, in the Wireshark, we're not going to see DHCP. We're actually going to see the previous name they had, bootp. So that's why I put it here. Then we have the DHCP v6, for example, and Slack, stateless address auto configuration. This is dynamically assigning, automatically assigning IP address to the IPv6 device. Here is IPv6 device assigning IPv6 address to itself. um, Email, this is for sending email, simple network mail transfer protocol, simple network mail protocol, POP3, receive email, and IMAP to receive email. So we have two protocols to receive and one for sending. Then file transfer protocol, secure file transfer protocol, and trivial file transfer protocol. This is just transferring files in your network. HTTP, HTTPS, and other protocols we have like syslog, NTP, and so on. At the transport layer, we have two protocols, two important protocols. There's more protocols, obviously, but two more important protocols that we need to learn for our CCNA curriculum is TCP, which is reliable. Make sure the segments are acknowledged, and if any segments gets missing or out of order, we're gonna resend it. While UDP is connectionless. Connectionless meaning that the source doesn't ask the destination, "Hey, are you there? Can I talk to you?" While TCP does. TCP does that three-way handshake first, make sure that the destination is there and is ready to communicate. That's why it's called connection oriented. Now UDP is connectionless and is best effort. So it will just send the segments. Hopefully they get there to the destination. And then we have an internet layer. At the internet we have a NAT, NAT64, IPv4, IPv6, ICMP, v4, v6, and some routing protocols. And then we have a network access, ARP, Ethernet, and WLAN. So this is a protocols suite of the TCP/IP. Thank you for watching lesson 3.2, protocols and protocol suites. This is of chapter 3, protocols and models. Please have a look at my other videos and don't forget to subscribe to my YouTube channel to stay up to date with what I'm doing. This has been Astro Krasniqi. Bye bye.